This is the January 2019 Chemistry Regents Exam, Part A, questions 1 through 30, that we're going to go over here, and not just the answers, but how you know what answer to choose. So if you haven't checked out the January 2019 Regents Exam, you might want to go to the New York State Regents website and pull it up and maybe do the questions and then come on back for answers and explanations. You can certainly listen along with me as we go through the 30 questions. That's entirely up to you. I'm so glad, though, that you're checking out the video, because that means you're studying and getting ready to do as best you can on the Chemistry Regents exam. So with that, let's get started here. So these questions, 1 through 30, are typically going to be your definition type question and your facts. So there's information you just have to know in order to answer these questions. So let's get to it. All right, so for the first question, it's all about the gold foil experiment. Hopefully you remember this from taking the class. If not, this is Rutherford's gold foil experiment, which had two major conclusions, and that is the atom is mostly empty space and has a small positively charged nucleus. Those are just facts, and that is here choice 2. So this is a 2-for-1 type question, and what I mean by that, if you forgot one or the other, right, look at the first part. It's either empty space for choices 1 and 2, or a hard sphere, right, with a large nucleus. So right away, if you remember mostly empty space, you would cross out 3 and 4, and then it's just a question of, is it positive or is it negatively charged, and it is positive. So you need to know it. It shows up pretty much every Regents exam. All right, let's keep going here. For the second question, it says atoms are neutral because of, well, there are 3 subatomic particles, right, in an atom. Protons, which are positive, neutrons, which are neutral, or we say sometimes a teacher might say they have a 0 charge, and of course electrons that are negative. So if we have a neutral atom, that's going to mean our protons and our electrons have to be the same number, and that is choice 2. Also, don't forget your protons and your neutrons are found in the nucleus, electrons on the outside, and the identity of an atom is only based on the number of protons. All right, so for number 3 here, in the ground state, valence electrons of krypton are found. Well, whether it's a krypton atom or any other atom, valence electrons mean outermost electrons, right? Whether you want to call it a shell, a level, orbitals, which is really the correct term. So when I look at the choices here, it's of course going to be the outermost shell, which once again is choice 2. All right, for question 4, this is one of the top 7 vocabulary words that always show up. I have a separate video on that you should check out. So let's take a look. According to the wave mechanical model, that's the most recent model we have. We say that electrons are not in orbits, they are in orbitals. So that literally here, question 4 is a definition for the word orbital. Let's move on. Number 5, which electron configuration represents electrons in an atom of sodium in the ground state? Okay, so first thing is sodium. They don't give you the symbol. You can look the symbol up on reference table S if you forget that sodium symbol is Na. Then ground state means the lowest energy levels available. All of the electron configurations on the periodic table are for the elements in their ground state. So real simple. You're going to find the periodic table, and I'm just kind of flipping to it. Here's sodium. I'm sorry it's hard to see this on my iPad here, but sodium's electron configuration, or all electron configurations in the ground state, are in the lower left-hand corner. So for sodium, that's going to be 2-8-1. So all you're going to do is play the matching game. So let's go back. And sure enough, 2-8-1, here it is, choice 1. So remember, those electron configurations, you can find them on the periodic table, and those are all for the ground state. Question 6. Elements on the periodic table are arranged in order of increasing atomic number. So once again, number of protons is your atomic number. Your atomic number is your identity of an element, and that's how the periodic table is arranged. It's a fact. You need to know it. Let's move on. For number 7 here, which element is malleable at STP? Well, you need to know certain properties of metals, which is 2/3 of the periodic table, and properties of nonmetals, right, with the semi-metals in between. Malleable and ductile are all ways we describe metals, and that also would include things like good conductor of heat and electricity. They lose their valence electrons and become positive ions. Another way, if you weren't sure, you wanted to just check it out, find where these elements are on the periodic table. So once again, notice they give you the names of the elements and not the symbols. Chlorine is Cl, copper Cu, helium He, and sulfur is S. Don't take it for granted. You can look those up on reference table S. Then what are you going to do? You're going to go ahead, you're going to go here to the periodic table again, and let me get rid of this, right? That was for the last question. And of course, now I got to remember the choices. But let's see. Helium was 1, sulfur, chlorine, and then copper. If you notice, of course, copper is with the metals. And these 3 here are nonmetals. So it's pretty obvious then my choice of copper is the right answer. All right, let's move on to number 8. So for number 8, we're looking at which noble gas has the lowest density. Well, for densities, of course, those are listed once again on reference table S. There's a lot of information there, and students forget to look there. Another way, of course, that we can check it out is that if we had the same volume of these 4 noble gases, if I go back to the periodic table and I erase all of this, that as I go down the periodic table, the masses are going to get larger and larger for the same volume. So they didn't have helium as one of the choices, but then they had neon, I think argon, krypton, and xenon. So the answer is neon. And if I come on back, here it is. It's choice 1. You don't have to take my word for it again. Reference table S is one of the most neglected, yes, that's Redford barking, one of the most neglected reference tables that students take a look at. Again, you got all your names over here, that then you have your symbols if you need them. You got all these other pieces of information right now on that question where we're looking at density, so you could literally pull them off. Helium was not a choice, and you'll notice, again, neon is the least dense, which was the answer. So let's go on back. Okay, so neon was the answer for number 8. Let's move on to number 9. All right, so which 2 terms represent types of chemical formulas? All right, so there's a bunch of different ways we describe chemical formulas, right? That's the symbols or combination of symbols. So for individual elements or for compounds. Sorry, I just had a little bit of a brain cramp there. And the answer is actually going to be choice 1. Empirical and molecular, they have the word formula after them. Empirical formulas is your lowest whole number ratio. Molecular formulas is the actual compound formula. Polar and nonpolar just doesn't make sense. That's used to describe either bonds or molecules. Synthesis and decomp, those are types of reactions. In saturated and concentrated, well, that describes solutions. So the only answer there is choice 9. If you got to use process of elimination, go for it. And notice, look at this page. I'm messing up. I'm writing all over the test paper, and you should do that as well. Moving on to number 10. Now, which quantities are conserved in all chemical reactions? Well, students remember conservation of mass and conservation of energy. But the third one that a lot of times we forget about is charge. So conservation of charge. So there's 3. Why do we forget about conservation of charge? Well, because most of the time when we're looking at reactions, we're looking at, if they're compounds, we're looking at the compound together. And of course, our ionic compounds, when you put them in water, they break apart into ions. Or with redox, we're pulling down what's being reduced and what's being oxidized. And then we have to worry about conservation of charge. But a lot of times for reactions, we just see the entire formulas of everything, and we don't realize that, again, we have conservation of charge as well. So those 3 are it. You should know them. All right, let's keep moving on. We're up to question 11. For question 11, which term represents the sum of atomic masses of an atom in a molecule? All right, so if it's the sum of masses, first of all, you know darn well it's not going to be the atomic number. That doesn't make any sense. Okay, it's the sum of atomic masses. That doesn't make sense for mass number either. Mass number is just the number of protons and neutrons in a nucleus. Formula mass, now we're getting somewhere. Remember, formula mass is the mass of either an individual element or a compound, right, where I take an atom inventory, the number of atoms and their masses, and then I add them up. And if I'm adding them up, one of the ways we describe adding, of course, is the sum, S-U-M. So percent composition isn't going to be it either because, of course, that's part over the whole thing times 100. So there's my answer for question 11. It is choice 3. Moving on to the next page. Okay. So for question 12, which equation represents energy being absorbed as a bond is broken? So this type of question, oh gosh, does it show up a lot of the time? If energy is being absorbed, that means energy is a reactant. We're going to see it on the left-hand side. And the only choice here that we see energy as a reactant, sure enough, is choice 4. And look what we have. We have H2, and then it's separating into the 2 H's. So there's our broken bond. So choice 4 is the answer. For number 13, which term is used to describe the attraction that an oxygen atom has for electrons in a chemical bond? All right, well, this is, in my opinion, the vocabulary word that shows up the most. And sure enough, here it is, just from the January 2019 Regents exam. That word is electronegativity. Now, it can be any atom. It doesn't have to just be oxygen. But an attraction that any atom has for electrons is known as electronegativity. The electronegativity values for all atoms are listed on reference table S, so it might show up again on this test, but you have to know the definition. Please check out my other video, right? So far, we've seen 2 of the 7 definitions that show up pretty much on every exam. Okay. Enough of that. Let's go on to 14. Which substance cannot be decomposed by chemical means? In other words, which substance here is an element? Because if I'm going to break down an element, now I'm going to break it down and it's not going to be that element anymore. The other choices, right, 2, 3, and 4 are all compounds. They can be broken apart into their elements. So the only answer that makes any sense here, that's our element, is choice 1 for 14. Okay, for 15, a beaker contains a dilute sodium chloride solution at 1 atm. What happens to the number of solute particles in the solution and the boiling point of the solution as more sodium chloride is dissolved? Well, this is known as colligative properties, and what that means is that when I have pure water, we know that pure water, we say it boils at 100 degrees Celsius and it freezes at 0. But as soon as I put something that dissolves in water, it raises the boiling point at the same time it lowers the freezing point. So in order to do that, we're going to add solute particles. The more we add, the more the boiling point gets raised and the freezing point drops. In this question, then we're looking at solute particles increasing, which crosses out 3 and 4, and then of course the boiling point increases, which is choice 1. Now we're on to 16. Which form of energy is transferred when ice is placed in a beaker of water? Okay, so forms of energy. Chemical energy is energy that's stored in chemical bonds. We're not breaking any bonds here, right? We're just going ahead and we're changing the attraction between the molecules. That's not going to be the answer. Electrical energy doesn't make any sense here. We're not putting any current through. Nuclear energy would be something that would be happening with the nucleus of an atom. So sure enough, and you probably already knew, it was thermal energy, right? Energy that's transferred always from hot to cold. Let's go to 17. Oh, here it is. Another one of our vocabulary words, right? The average kinetic energy of particles is expressed as temperature, folks. You got to know it. Temperature, temperature, temperature. All right. Move on to question 18. This is a classic question. I'm going to say pretty much once again shows up every time, and that is, at STP, which gas sample has the same number of molecules as 2 liters of methane? So if I'm at STP, right, we have the combined gas law. I'll just give you a little bit of background, right? PV over T is equal to PV over T. At STP, that means that the pressure, they're both the same, temperature's both the same. So guess what? If I have 2 liters of CH4, doesn't matter what gas it is. If I got 2 liters of another gas, sure enough, it's going to have the same molecules. So you're always looking for the same volume here, which is choice 2. For 19, which phrase describes this change? Well, solid directly to a gas. You got to know it is sublimation, although they're not asking that. They're asking about endo-exo, and then is it a chemical or a physical change? Well, in order to go from a solid to a gas, think of it this way, right? Solid to a liquid that's melting. You know darn well that if you're going to melt something, let's say you're throwing something, butter in a pan on the stove, you're going to turn on the stove to get that butter to melt. That's solid to liquid. Well, the same direction goes solid directly to a gas. So they're not asking about the term sublimation. First thing is endo or exo, and it is endothermic. So let's get rid of 3 and 4. And then is it a physical or a chemical change? It's physical, because all we're doing is changing the phase, which is choice 2. All right, rolling right along. Let's check out 20. Which term identifies a factor that will shift a chemical equilibrium? All right, so chemical equilibrium means between reactants and products. Not that the concentration of reactants and products is the same, but the rate at which the forward reaction is equal to the rate of the reverse. So the only thing that's going to shift the equilibrium permanently is temperature. Probably if kids were going to make a mistake here, or you were going to make a mistake here, it would be thinking maybe catalyst. But remember, catalysts are going to speed up both the forward and the reverse. So that's not a good answer. Atomic radius doesn't really make any sense. And decay mode has to do with what's inside of the nucleus of an atom and whether or not it's breaking down, hence decay. So that's not it either. So the answer there for 20 is temperature. All right, for 21, according to which theory or law is the chemical reaction most likely to occur when two particles with the proper energy and orientation interact? Okay, so we know this as the collision theory, that not only do particles have to collide, folks, but they have to have enough energy and at the correct angle or orientation. It is a fact. Just know, hence collision. All right, let's go to 22. Addition of a catalyst can speed up a reaction by providing an alternate reaction pathway that has, well, we just mentioned this before, but it would be a lower activation energy. If you recall your potential energy diagram, whether or not you're dealing with the forward or reverse, and the forward here is exothermic, right, because I'm starting higher, ending lower, or the opposite then would be endothermic. But where the catalyst comes in a potential energy diagram is right in the middle. It changes the activation energy, and it actually changes both the endo and the exothermic. So if I want to speed up a reaction, I want to lower this activation energy, which is choice 1. Moving right along for 23, which compound is saturated? Your saturated organic compounds are going to be your alkanes. And alkanes mean you have all single bonds between the carbons and you have an ane ending. So the only one there that fits is butane. Choice 1. All right, we got these last few to do, and we're done with Part A. So for 24, an alcohol and an ether have the same molecular formula. These two compounds, well, do they have the same or different functional groups? Which means then what's going on as far as properties? Well, if you go to reference table R, here they are, alcohols and ethers. They definitely have different functional groups. With different functional groups, they're going to have different structures. Different structures always mean different properties. So different functional groups, different properties, and that would be choice 4. For 25, which metal is most easily oxidized? Metals want to lose. So what this is asking you, which one or which metal wants to lose its electrons the most? The easiest way to look at this is to look at reference table J, which I think I have here. Here it is. So what I did was I put the choices here. Okay, most active means wants to lose electrons the most, with lithium at the top, and the least active wants to lose the least. So we're talking about the metal side here, so magnesium is going to be our answer, which is choice 4. Okay, for 26, which substance is an areneous acid? I don't have the reference tables here, but there is a reference table for common acids and a reference table for common bases that you can take a look at. But an acid means that I have H in the formula and then the rest of the molecule, and sure enough, HCl is our answer. I believe their reference table K is I think acids and L is bases, so check that out. So look it up to just double check. Question 27, electrolyte. Now here is another one of those vocabulary words that shows up pretty much every Regents exam. What does an electrolyte do? An electrolyte, first of all, dissolves in water. And not only does it dissolve in water, but it can conduct an electric current. So there it is, choice 3. For 28, which type of reaction occurs when an acid and a base form salt and water? Acids and bases neutralize one another, which is choice 3. For 29, compared to the energy released per mole of a reactant during a chemical reaction, the energy released per mole of a reactant during a nuclear reaction is, oh gosh, it is much greater. That is our fusion and fission reactions. So those are the, unfortunately, reactions of atomic bombs, but also of nuclear reactors. So there's some bad and good that goes along with that, but it is much greater. That's a fact. Just know it. And finally, for number 30 here for Part A, which phase describes a risk of using, of course, cobalt-60, which is a radioisotope, which means it's undergoing nuclear decay in treating cancer. And, of course, it is going to be about the fact that somebody has to probably ingest, or it has to be injected into their body, so there would be some increased biological exposure. All right, so this is it for Part A. I'm doing a separate video for Part B1. That's the other 20 multiple choice, so you can get an idea of the difference. There's some calculations there. There's some looking at either graphs, tables, and still some facts and definitions you need to know. And then for parts B2 and part C, that's all your short answer questions. So check more out. Keep working hard. I hope that you got something out of this video. Check out all the other videos that I have. And thanks so much for watching.